What if I told you that the 50 junctions across Bangalore that have Bengaluru Traffic Police's intelligent traffic management systems are not living up to their whole potential? They have a YOLO class identifier which identifies whether a vehicle is passing by or not. And it's great. It's great at its work, but it can live up to do much more. The only thing that tells you that there is a vehicle at this location. What it doesn't tell you is what types of violations it is committing over the period of time. That is what my system aims to solve. Here's a more concrete version of that problem. Imagine a car is parked illegally on a footpath and the car stopped there for 3 seconds to drop someone off. Pixel for pixel, for every single frame, the look is identical. The same bounding box, the same confidence score. What's different is everything outside the box. Now, there's a restricted zone. Was the signal red? And how long was it actually sitting there? So instead of trying to train a detector that magically knows the difference between which isn't really possible in one frame, we built a context layer that sits on top of the detection and answers those exact questions for you. Let's come to the pipeline of this project. This is the most important part of this presentation. Why? Because this is where all of the processing happens. This is where we run everything. Let me explain how everything works then. First, the image comes in with its location and its timestamp. The location and the timestamp are only for metadata purposes. The image goes through pre-processing. What does pre-processing do? There is something called CLAHE, which removes low light, shadows, and especially in the monsoon season or in the summer season when the sunlight falls on the cameras or basically does anything that would disrupt the video and the photos quality, it tries to reduce that. Why? Because YOLO V8 cannot handle hazy and blurred photos very well. This pre-processing is very much necessary and it also reduces the image data. So it reduces the file size of the image so that it can be efficiently processed. Now, next coming to spatial and temporal reasoning. This is the entire point of this project. Spatial reasoning is already done by YOLO V8. It knows already where the vehicles are and where the restricted zone is. Temporal reasoning. Now, every single frame is compared with every other frame. For a video, we keep a precedented dwell time for which a maximum amount of time that vehicle can be there in the restricted zone. Suppose someone is dropping off someone at a zebra crossing. That is not a violation. But if someone has parked the car there for more than, let's say, 5 minutes, that is now a violation. That can only be done with temporal reasoning. You can't do that with spatial reasoning alone, which is currently happening in Bangalore. Now, let's come to the more technical parts of this. After that, the violation classification is taken, which gives us a rule based result. After that, the historical intelligence enrichment. Now, BTP has its own data. That data is used to compare the violation, and we can basically form a sort of statistical analysis based on that. After all this, the model gives us a confidence score of how confident it is whether it is a violation or not. Okay, now, as for the MVP, I decided to scope down on parking and obstruction specifically. No parking, footpath parking, carriageway obstruction, double parking, restricted zone, etc. I deliberately deferred wrong side driving, red light, triple riding, and helmet or seatbelt. Now, I have three really good reasons for this. First things first, BTP's own records state that the strongest existing label base to validate against and the zone overlap plus the dwell time is the most reliable signal we can pull from a single camera angle without needing to separate a signal state data piped in. And honestly, the violation class that benefit most from the video upgrade are exactly these ones. Carriageway obstruction, double parking, both live or die on how long was the vehicle actually there. And that is now measured in a signal instead of a guess. Now let me show you how the MVP actually works. As you can see here, this is a video that is there already on the website. You can visit the website is functional. Now, do we can draw our own zone polygon right here. So we go here. Let me just quickly draw it for you guys. Yeah, so that is the zone polygon. I will apply the manual zone now, and we can see that the manual zone is applied. If I click on execute video inference, what will happen now is it takes multiple of those frames. This video is around 31 seconds long. So for every single one of those 31 seconds, it takes two frames for every 60 frames that are there. And for if a vehicle is standing there for, let's say, here I have kept it as 10 seconds, it will be marked as a violation. Now here is what I have produced from a video. As you can see, YOLO V8 is currently detecting the vehicles that are there in the frame. It takes two frames every 60 seconds, and for every single one of those frames, runs pipeline. Pipeline. As we saw, there was no vehicle that stood in the same place for more than 10 seconds, and hence it didn't mark it as a violation. But now, here, we can see different 12 seconds, whether it is confirmed as a violation or not, and the track ID. Every vehicle is given a new track ID. Every single frame identifies its own vehicle. So, but now it tells you exactly how much time each of them were there in the restricted zone for. Now, none of these are confirmed. How much? One more thing before I start on the architecture. The historical layer isn't trained on synthetic data. It is built on BTP's own published OpenCity datasets, traffic violation records, and road crash data. Coming to the deployment, this is an edge first by design, not cloud first. Frame filtering, the detector, centroid tracking, polygon checks, all of that runs near the camera. Only what's worth sending violation candidates, cropped evidence, metadata, that is what goes to the cloud, where historical analytics, evidence storage, and dispatch interrogation live. The reasoning is simple. Edge inference trades some real model capacity for low latency and the ability to keep working if connectivity drops, which matters more across 50 plus junctions. Cloud trades latency for analytics depth and centralized retaining. Neither layer is doing the other's work. Each task sits where it's actually suited to run rather than running everything in the one place because it's simpler. Because this feeds an actual enforcement flow, the system doesn't just output a label and walk away. Every detection gets routed by confidence. High confidence goes straight into the enforcement queue, medium gets routed to an officer for manual verification, and low gets logged for analytics only. No action is taken. The model decision is support, not a decision maker. In anything ambiguous, a human officer will still make the call. That matters a lot here. A false positive in this case isn't a bad metric, it's someone getting wrongly flagged. And every one of these decisions produces an actual evidence package: annotated frame, violation type, confidence score, location, and timestamp. The rule that triggered it, reviewer's decision, is also included. Nothing is a black box. Let me just show you what it really looks like running for real. Since you guys have already seen me running the video, I wanted to show you what happens frame by frame here. Let me just draw the violation box that is supposed to be there. Now, I click on apply manual zone, and the manual zone is applied. I click on execute spatial inference, and the result is immediate. This is what is happening in the video as well. Now, to show you the metadata of the photo itself, here it is. It tells you why it flagged it, the confidence score, the risk assessment, everything. If there is a historical violation type that matched it, yes, it will show you that too. Quickly on the evaluation, vision metrics, precision, recall, F1, MAP tell you everything how good the detector actually is. If it's actually deployable, the latency, the throughput, the false positive rate, reviewer workload, everything. Because a model with great MAP that floods officers with false positives isn't viable on the field. License plate OCR, which we are scoping for phase 3, is a separate lightweight pass. Paddle OCR on the crop plate region evaluates on its own. Where does the pipeline go from here? It has four phases. The first phase is what you're looking at, the parking and obstruction MVP, the current state. Phase 2 is the pilot deployment with the officer review in the loop. Phase 3 expands violation coverage and adds OCR for the plates. Phase 4 is a city scale intelligence layer, and each phase deploys independently on the same backbone. Nothing here needs a redesign to get there. At the end, I would just like to tell you that the traffic cameras in the city are already capturing all of this, citywide, every single day. What is missing is the context that turns that footage into something an officer can act on and an auditor can check. That is what this is. Thank you for watching. Bye.